Hi there, hello everyone. I will try to actually explain a few things in this talk. This talk will not be a technical talk. This talk is more a business talk and covering some kind of aspects of functional programming and post-functional term in software development process and in delivering of software solutions to customers. So that's the title of the talk: delivering user value in a post-functional world. Let me introduce myself one more time. My name is Rafał Pokrywka. I'm actually founder of Virtus Lab. Virtus Lab is a type-safe partner in Kraków here. We are mostly doing work in Scala. Actually, all of the projects are right now in Scala, so that's a good thing, definitely. I've also founded the Kraków Scala users group with other Juke members, with friends from community, and Scala Camp, which is also organized by Kraków Scala users group. This is a cyclic meeting about Scala in Kraków. We had fourth edition recently, so they will definitely be more. Okay, so let's get back to the topic. Is there everything okay with the speakers? Am I heard correctly? Cool. Okay, so let's go through those three things. That is delivering, and what we will deliver. That is user value. So this means what is important actually for the end users, that and the term post-functional. Post-functional world, that was a term coined first by actually Martin Oderski, who in 2010 wrote a blog post. That blog post was actually an answer or response for other voices from the development community about the topic that if the Scala is actually functional. And Martin Oderski argues, or actually try to explain a few potential aspects and clarifies what is actually the place of Scala in the landscape of programming languages. And sorry for that. The details actually of this blog post includes actually agreements that Scala actually is functional. It means that all of the critical features of functional programming paradigm or functional paradigm are presented in Scala. That is, for example, functions as a first class unit, higher order function, promotion of immutability, and pattern matching, for example. And the difference between Scala and other functional programming languages is that probably Scala has its roots in JVM and Java, and in JVM and Java syntax. So, in the same time, Scala also embraces the object-oriented programming. I mean, all the aspects of object-oriented programming are also available for software developers in Scala, and this is kind of a different approach than other languages, also based on JVM, took when it comes to the functional programming. For example, Clojure. Clojure is meant to be more a pure functional language, which I should not have said a pure, because it's not pure in a sense that Haskell is, for example, but it's definitely rejects aspect of object-oriented programming, to some extent, of course, and it definitely has different syntax. So basically, the syntax of Scala has its roots in Java, so that's why it may be a bit easier for Java community and software and Java developers actually to take advantage of and to try. I will just take a few drops of water. Sorry. Okay, excuse me. That's a bit better. The same term, that is post-functional, has been used by and promoted actually by Daniel Spiewak in his presentations. I think it was in 2013 the first time he presented that. He presented the functional programming and object-oriented programming together, showing the kind of things that are potentially missing in some part in functional programming or in object-oriented programming. And the conclusion of his talks actually was that the key thing in the next step in evolution of programming languages is modularity. And modularity and module system is something that is to some extent actually covered by traits in Scala and some other aspects in functional programming closure, for example, protocols. And but the end conclusion is a bit deeper. I mean, I don't like to enter into the details of functional programming or object-oriented programming and comparing those tools, because the final conclusion actually of both of those the blog post and the presentation is that functional programming alone may not be enough, and the history actually shows the same. That is, when the Lisp has been first introduced, for example, somehow it was a hard way for software development and for software business to embrace actually the power of Lisp and use it in the mainstream. Actually, people and developers stayed somehow in using the Fortran, for example, or imperative languages. This shows that somehow functional programming alone, or only using the functional programming functional paradigm in software development is actually not enough, and people always looked at other ways of solving some problems. It's, of course, depends on the kind of problem, but it appears that the evolution of programming languages has to actually involve both the functional programming style and object-oriented programming as well. So that's something that is definitely needed, and this is something that gives the software developers additional tools, or the broad range of tools, to wisely and actually consciously use in solving real-life programming problems. Okay, so the post-functional means actually, for me, another step in the evolution of programming languages. Actually, it's the natural step that allows software developer actually to take advantage of those practices. I will explain that in a minute, how this relates to user value and delivering. But this is a key thing, that it's actually standard normal evolution. Okay, so let's move ahead. Let's move to explain a little bit more about user value and what this actually means. Because we've mentioned about programming languages, we've mentioned about the possibilities they give us, as software developers. They are different ways of expressing the same thing. We can use something that has the most hype already, or in the current moment in time. But that's something that is not probably the best thing in a given example. I mean, from the problem perspective and from the user perspective, this is somehow decoupled. I mean, the programming and playing around with the in the sandbox with all those new tools, new possibilities that the next programming language will give us, does not actually gives is the best way to try to deliver user value. I mean, to focus on what is the most important thing. The user value actually is something what we, or delivering user value is something what we as a software development business does, and what is the main purpose actually of our work, our daily work. So when actually a customer comes in and the customer just would like to make an investment into some new system that will allow the customer to scale his business and make, for example, a better profit, or just adds another source of revenue, or whatever other the reason is. In most cases, that reason comes from fundamentally from the customer business, and from his side, from his needs actually and requirements. And this is the same kind of investments actually as they are made into, for example, new production line. If a business in a given sector would like to expand somehow, would like to add another product to its offer, they just invest for example, in a new production line, which is a simple investment to estimate, and actually simple investment to estimate the return of it. So the main expectation usually is for the customer is to actually provide or assure that he making that or she making that investments will achieve the return of simple value, return of investments. I mean, this is the potential additional profit he can make. So basically, that's what the value usually is for the customer. The system as it is should or should not fail also. That is, should not have the hidden bugs inside that are resulting in a failure in a production environment. That's even if we meet the requirements, even if we gather the requirements correctly, and we fail to actually develop that in a correct way, that's something what simply can be a total failure for the customer. He can lose a lot of money because of that. And the other aspect of a software system that we need to deliver is that the system does the job efficiently. That is, for example, it scales as the need of the business scales as well. It can handle peaks of the load, for example. It can be efficient. It can just efficiently use the machines or the infrastructure under it. It simply have some kind of set of non-functional requirements. Just to sum up, what the user value is definitely as user, the end user, the business user gets the value if the system is correct, if the system meets the requirements, and if the system meets the non-functional requirements, functional and non-functional requirements, of course. Okay, so there's the last or final aspect that is delivering, and delivering is the actually step that needs to be done, because before actually end user or business user will get enough value from it. Actually, it must be delivered. Actually, so simply. So, what guarantee usually the customer has if he is buying bespoke software when it comes to return of investments and delivering of the end solution? There is a certain number of research done. One is by Standish House. It's a group that does some polls annually, I guess, and it just asks management if the projects they are taking part in succeed, failed, or be challenged. Challenge means that they are over time, over budget, or without meeting the final requirements. And succeeded means that the software has been delivered on plan. The failed means that it has not been delivered at all. So in 1994, we had the succeeded rate of 16%, failed 31%, and challenged 53%. And in 2004, the same research shows that we had succeeded in 32% of the projects. We have failed in 24, and 44 has been challenged. In 2005, another research by KPMG shows that 49% of companies experience project failure, and 86 of them experience shortfall on ROI expectations. In 2007, another poll, another article that's in the Dr. Jobs journal, it says that 70% projects are doomed to fail from the start. It means that basically they are not validated, estimated, they analyzed good enough actually, and it's known that they are doomed to fail. In 2008, 30% of projects has been successful in government projects. This is by Guardian newspaper, information by Guardian newspaper. It means that 70% has been just a failure. In 2010, 70% companies experienced project failure, and 50% of them experienced shortfall on ROI expectations. And in 2011, actually, there's another article that shows that business is usually out of the sync with the project requirements. It has been a poll. In 2012, actually, there's another information that 70% of IT projects go badly, and so badly that they can threaten the existence of the company. So that's all of that research shows that we have done little progress in delivering user value to the business customers. So basically that shows that maturity of software development process and software development business actually and sector has a long way to go actually to reach some kind of acceptable levels. If the construction works had the same success rates or failure rates, we would have more of this. Definitely more of this. We have only one actually in Krakow. There's a certain number of case studies. I would not like to enter into details of it, but there was one example of universal credit, which should be delivered in 2013. It has been totally reset in planning in 2013, so total failure. It just shows that we are probably doing the programming and software development completely wrong. This is the sentence. I'm not sure if this is visible enough, but this is a sentence by John McCarthy. John McCarthy is the inventor of Lisp. So the question is why we fail to deliver value. Is it because of the software development complexity or the domain complexity? And the simple answer is that it's both. But what we can do with it? We can do something with domain complexity or essential complexity by improving on our requirements, but we can do a lot more in reducing accidental complexity in software development. And the evolutionary step of returning to functional paradigm is actually a step that consciously allows us to reduce accidental complexity. And one of the basic things in reducing accidental complexity is immutability, that is avoiding mutable state. When it's not a good thing actually to have some mutable variables all over the place, and so you can't even reason about it and debug it correctly or efficiently when you have something changed in one place or in the other place without maybe deterministically in a simple case, but at the end it turns out to be pretty much undeterministic. There's also another thing that functional programming brings. This is the awareness of side effects. Awareness of side effects. I mean, it's impossible actually to avoid or to not have side effects at all. But if you know where your side effects are, that's the big step ahead. If you consciously can actually avoid side effects in parts of your software of your software, if part of your code, it turns out that the code at the end is really better in terms of testability. I mean, its testability increases, and if you can't test your code is probably totally, or maybe not totally, but it's not the biggest, the best. It's not the best quality of it. There's one more aspect, that is referential transparency, and the referential transparency means that, for example, function gives the same output concerning the input, and this is actually the consequence also of reducing or not allowing for side effects in synchronous areas of the system, but it can result in a simple pieces of software that can be easily composed together and can be tested in isolation. So that's still improved. That improves also testability. And we have a first-class functions. That is, functions as a first-class units, which can be composed together. And this is, as a consequence, we can have also higher order functions. All those things are actually all modern programming languages, which are functional to some extent, support all of those 4 traits, but they actually help us to as software developers to use them. But it's possible actually to follow those best practices also in other languages, which does not actually support functional programming in an explicit way. This just means that all those 4 things are just best practices that every day you, as a software developer, can use, and as a result, you get the system, you get software that is testable and that potentially is of a better quality. This is the statistics from one of our projects. Actually, we have in Scala we have 2,671 values compared to 10 variables. Variables means actually a variable, and vals means just vals. Vals mean values, which are basically immutable values, simple values, and that shows that avoiding mutable state actually is pretty much possible, and we can program that way actually. I would like to show you also the broader scope in a timeline where we are and what is the potential evolution steps ahead, and just to speed up, we had some kind of evolution of generation of programming languages ahead. In one time, actually, there is a point in time when the community decided to return to functional programming to some extent. Also, the Scala appears, or other languages on the JVM that support that, or not on the JVM that support functional programming appeared. And this is on a timeline. We, in the same time, in parallel, experienced evolution of other parts of the software development business, that is, for example, test-driven development, or Lean Kanban, or BDD. It's all actually moves us to some time ahead, and in 2015, 2013, we God knows what the languages will be, but we definitely will follow some path of evolution. This path of evolution, the main thing in this evolution is increase of maturity of software production, of software development, and with each year, probably the success rates of projects will increase. But to be honest, at this moment there is no research that can tell if functional program using or reusing functional program or returning to functional paradigm will have enough impact on the success rates of the software projects. But in my opinion, those 4 things I've mentioned about functional programming paradigm, functional programming, is one step ahead in the evolution of the maturity of software development systems, or software development. So let's hope that will happen. Are there any questions for that?
Questions? Why did you choose Scala as a technology for your software house, and what it gives you? What advantage it gives to your business?
There's quite a big advantage actually of Scala as a programming language itself. So comparing, for example, to Java, of course, the introduction of functional aspects of an object-oriented and actually merging it together is something that has a great advantage for us. It means also that we can quite easily start with Scala on the JVM and move from the Java style to the more functional style in a gradual way. Everyone faces troubles with hiring. This is the common thing. Even if we had a full bench of software developers, actually, it's always you always have to choose. Actually, you always have to choose the correct personalities to your team, to your correct skill levels to your team. So basically, that's a tough job. Hiring is a tough job. It is, to some extent, but the better the technology, the better the people who are using those technology usually. That's the usual case, at least at the beginning. At least at the beginning, but, okay.
Questions? Yes?
From your experience, you've been doing it for some time. From your experience, what's the uptake of Scala in Poland? What's the
Adoption rate and growth rate? When it comes to Polish companies, actually, there is a few examples that where the Polish companies already uses Scala in production, and those examples also include business from other sectors, like for example manufacturing sector. So basically, this manufacturing sector in Poland is willing to use new technologies, including Scala, actually to gain some advantage or competitive advantage. So that's the example from the business side. Actually, there's also examples of software houses that adopt Scala as a technology that is getting more and more adoption abroad. That just simply to have the skills level to be able to develop systems for customers.
Okay, let's thank our speaker.